Good morning, everyone, and welcome to the Daily Math Challenge number 8. We've got questions on probability today, so let's get stuck in. Okay, so to begin with, we've got the bronze question. I have 5 containers of milk in my fridge. 2 are off. I don't have any labels on them, and I have no way of telling the difference between them. I'm making milk from one of these containers, chosen randomly, to make tea. What is the probability that I've used bad milk? Now, this is an Englishman's nightmare. However, let's see actually how worried we have to be. What's the probability that actually we're using some bad milk? So I want to recap very quickly what probability is. So basically, you know what, it turns up in so many different situations and there's so many different ways of thinking about it. But if you have various things that could happen in a situation, let's say, the classic, you're taking some sweets out of a bag, or in this case, you're choosing something out of a selection. With probability, basically, we want to understand how likely something is to happen. So let's say that the thing that we're interested in is the event choosing a red sweet from a bag of Skittles. Well, if you want to work out how likely it is to choose a red sweet, it makes sense for us to first of all work out how many red sweets there are, and how many sweets there are in the bag. So if there is literally only one red sweet amongst a bag where every other color is different, can you see that there's no reason why you should choose the red one over all of these? So that's not that much of a chance of choosing red. However, if let's say 1, 2, 3, 4, 5, 6, 7, so let's say that we have 4 of them being red and 4 of them not being red, then it's much more likely you're going to choose a red sweet if you choose one of those at random, right? So because you can either choose a red or not, and there's actually half of them being red in this case, so you have a probability of a half of getting a red sweet. Now we have the vague sort of idea of what it means for something to be like to for it to be likely for something to happen or not. Let's think about how we actually define this mathematically. So we say the probability of an event happening is the number of ways the event can happen. Now, by event, I mean, like choosing a red sweet, or it raining today, or something that can happen where you're maybe you're doing an experiment, or you're looking at a situation. It's like an event in that situation is something that could happen in that situation. So it's a number of ways the event can happen divided by the total number of outcomes possible. Okay, so now this only makes sense if all the outcomes are equally likely. So here, it was equally likely to choose, you're equally likely to choose any of these. So we say that the number of outcomes, if we're looking at the probability of choosing a red one, we would say that the total number of outcomes is, well, if we can think of the outcomes as which one of these you choose, imagine if you could distinguish between the red ones and each of these. Let's say you labeled them 1, 2, 3, 4, 5, 6, 7, 8, and you wrote that on the sweet. Well, there are 8 different outcomes possible. Okay, we could choose any one of these 8 sweets, and each of those would represent a different outcome. And what's the event in this case? Well, the event in this question, by PI I just mean probability. What's the probability of choosing a red sweet? Well, the number of ways that this event can happen, where the event is choosing a red sweet, well, that's 4, because each of these is an outcome that could happen, and there are 4. So there are 4 outcomes that would result in choosing a red sweet. There are 4 outcomes that result in the event happening. So we say that the number of ways the event can happen is 4. 4 ways out of the 8 equally likely ways, things that can happen. Now, okay, I think we're ready to return to the question. So back to the Englishman's nightmare. So we have, how many did I say again? I think I said 5. Yeah, I said 5. Okay, so we have these containers or cartons, whatever they are. 1, 2, 3, 4, 5, and we're just assuming they're identical. You can't really tell the difference. Now, 2 of these are going to be bad. You don't know which ones are. So what's the probability that you choose bad milk? Well, we need to do the apply the formula, don't we? It's the number of ways that the event can happen. So two in this case, the event is choosing a bad milk, and there are two different ways we can choose bad milk here, and there are five different outcomes, right? We can choose one of these at random, so there are five different things that can happen. Either we choose this one, this one, this one, this one, or this one. Five different ways, equally likely. So that's 2/5. Now that is less than a half. So basically, you are more likely to choose, if you just look at this maths, you're more likely to choose good milk compared to bad milk. And that makes sense, doesn't it? Look, there are only what's it called? 2 cartons of milk here and bad milk, and 3 cartons of good milk. Remember, probability is always in between 0 and 1. 1 being certain. So for example, the probability that you are going to subscribe to my channel is 1. I'm joking. But anyway, yeah. So the probability that, I don't know, like the sun rises today is going to be 1, okay? 0 is something that is impossible. So for example, rolling rolling a 1, if you toss a coin, like there's no outcome that corresponds to 1, that's impossible. It also could be, something else with the probability of 0 could be the probability that you get a reasonably normal year in terms of weather in the UK, like I don't even want to go into it's so funny because like at school, like there's a kind of a joke amongst teachers that, as soon as the summer holiday begins, like the weather kind of turns a bit and it starts to rain and it's quite cold. And literally this year, it was so funny, after having said this a bit between different, teachers, I kid you not, I think it was the day that the summer holidays started for most kids in the UK, or maybe the day after, it was so hot before, and then suddenly it just switched and went just rainy. I just thought it was hilarious, but anyway, so yeah, so we have that probability. And remember, anything with a probability of a half means it's equally likely to happen or not happen. Okay, so tossing a coin, you're equally likely to get heads or tails, so that would have a probability of a half either way. Okay, let's go on to the next question. So what is the probability of having 7 sons in a row if we assume a mother is having, oh bless her heart, is having 7 children, and each child has an equal probability of being a boy or a girl, and each gender is completely random and independent of the gender of the other children? So we have 7 children. Gosh, this lady is definitely gonna go through some pain getting these 7 kids out, I tell you that. Childbirth is so intense. Anyway, I don't know why I'm talking about this is not my realm. Okay, so the idea, we're going to return to this equation here. So probability that an event is happening, so it's the number of ways an event can happen over total number of outcomes. So what's the event here? Well, we're looking at the event that is 7 boys, and what are the different things that can happen? So if we just thought about the first child, the different things that can happen. Let me just move this up. Right, the first child number 1, is it could be a boy. Oh gosh, I mixed that up. A girl or a boy. Okay, and each one of those is equally likely, right? Child number 2, same thing, equally likely for that to happen. But let's think about, after 2 children, what are the different things that could have happened? We could have either got a girl and then a girl. We could have got a girl and then a boy. We could have actually started off with a boy and then had a girl. Or we could have started off with a boy and had another boy. Now, if you think about it, these are going to be equally likely to happen, right? If you look at the same order. So, first child followed by second child. Because there's no reason why we should have favoured starting with the girl or starting with the boy. So each being in one of these groups is equally likely, as in the result of the first child. And then if you're in each of these groups, this one or this one, let's say that you had a boy or a girl to begin with, then look at the second child, because they have an equally likely, you're equally likely to get a girl or a boy, then it turns out that these 2 results are equally likely as well. So it turns out that actually each of these 4 outcomes, these 4 sort of sequences you have of boy, girl, or whatever you have, each of these are equally likely. So if we actually think about going through 7 children, let's look at the different sequences that you can have. You can either have like boy, 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 boy. Okay. You can have girl, 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 girl. You can have a boy, girl, 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 girl. You can have boy, 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 girl, girl, boy, girl, or whatever. You get me. Any combination of boy, girl you could get, and each of one of them is equally valid and equally likely. So if you think about actually how many different ways there are to do this, let's say that imagine like a tree, right? And the tree is like, okay, well, if I'm gonna have 7 boys or 7 children, I'm gonna like see the different things that can happen. I'm gonna split it according to like a tree like this, where if I have a boy the first go, I go up. If I have a girl in the first go, I go down. And then the second child, if I have a boy, I go up. If I have a girl, I go down. If I actually had a girl to begin with, I could either have a boy or a girl. So can you see there are loads of different things that can happen. So each time you're looking at one of these branches, each thing that could have happened, you have 2 more results that could follow after that, corresponding to what is happening with the next child. Now, if you think about how many different nodes there are at each stage, after the first child here, you have 2. After the second child, you have 1, 2, 3, 4, or 2 to the power of 2. After the third child, let's see how many different things could have happened, different sequences you could have got. Each of these original 4 or 2 squared results you could have got after 2 children. Well, for each of those, you have 2 lots of choices. So you have 2 lots of 2 to the power of 2, which is 2 to the power of 3. So that's after the third child. And if you keep going to the 7th child, the total number of different sequences that we could have got is 2 to the power of 7, which is a huge number. Let's just actually see how big that is. These are the different orders you can get. Now, 2 to the power of 7, 128 different ways, different sequences of having a boy or a girl, right? So now we're ready to actually do our little apply our formula, right? So it says that probability on an event is number of ways that the event can happen over the total number of outcomes. So first of all, the total number of outcomes, the total sequences of boy, girl we could get is actually 128. And how many ways are there to do the event, i.e. to get 7 boys? How many of those sequences corresponds to getting 7 boys in a row? There's only 1, right? That's if we're going up, then up, then up, okay? So that's just going to be 1, right? 1 over 28. Now, if you think about it, what that's saying is that if you were to, let's just assume there's nothing else, the hand of God isn't in this, obviously, I believe he's in everything, but anyway, if it's completely random, what would be the case would be if you were to go out to 7 children, and you were to do that with loads of different women, right? I'm not saying the same man with different women, whatever, you're looking at different families. Roughly 1 out of every 128 families, you would have get 7 boys. That's how rare it is, probabilistically. If you're looking at it complete randomly, that's how likely it is to get 7 boys in a row. So it is a really rare thing, if you look at it from a probabilities viewpoint. And that's just assuming that there's no other factors affecting whether or not you're going to get a boy or a girl. Okay, so that's that. I think we're ready to go on the next question now. Okay, a 2-year-old child is playing with 5-letter blocks. I had them jumbled in a random fashion on the floor before he started to play with them. After putting them in a row, he makes the word hello. How likely was this to happen if he didn't know how to spell? Okay, so we have a very potentially prodigious child in the making, but was this just chance? How likely was it that actually he knew what he was doing? So if we assume that he didn't know how to spell and he was just doing this randomly, if it's like a crazy probability, a chance that he would have spelled the right, like a word like that, then there might be something actually going on. Maybe our assumption that he doesn't know how to spell is actually wrong in the first place. So let's see how likely it was. So first of all, I have these blocks, H, E, I have 2 L's, and I have an O. So I had these all jumbled up at the beginning, and he had to order them. But let's see how many different ways there are of ordering. So if we want to work out what the probability that he spells hello when he could have got any order of these 5 blocks, let's assume that the different things that could happen are any ordering of these letters. Okay, so there are how many number of outcomes are there possible in total? Well, we need to work that out, but there's only one. Let's say that there's only one word that spells hello, right? There's only one word using these letters that can spell that word. So this is going to be one way of doing this event, i.e. choosing this word over the total number of words we can make with this sequence of letters. Now let's think about how many different ways there are to how many different words we can make. Well, first of all, let me look at how many ways there are to order the blocks. Let's say that I number the blocks 1 to 5. Now there is going to be a twist in what I'm going to do. It's not going to be exactly what you expect, okay? So I can either order it like that. I can order it by mixing up the H and the what's it called? And the E. That's another way of mixing them up. And you can imagine doing this where you can number these numbers or letters in any order, right? So, but the crucial thing to realize is that given a word like hello, or any word using these 5 letters, there are 2 different ways of ordering them if we distinguish the 2 L's. So if we did number these as 1 to 5, the reason why I did that is because I want to make it clear to you that there are for every word there are 2 different ways of ordering the blocks. So we could have done this or this. So whatever. So my L's are labeled 3 and 4. Okay, I imagine writing that physically on the surface of the block. The L's could be ordered like this or this. So these are 2 different ways of writing the same word, and that's really important because we want to work out how many words there are. Okay, but we don't want to count too many, right? We don't want to count one word twice. Anyway, let's look at this now. So how many ways are there of ordering? Well, we can imagine if let's say in front of us we have all of the words, all of the orderings of these numbers 1 to 5, where we've written them on the surface of the blocks, all the orderings that we can make using those 5 blocks. And I want you to imagine we're kind of like going to put them into bags, and at the end of this sort of tree, just like we did earlier in the other question, sorry, it's not, I'll explain after I've done this what I'm going to do, but basically I'm going to show you a way to organize them where it's easy to count how many words there are. So let's say if our sequence of numbers or the blocks begins with an H, that's the first one, we will group it into this group, okay? If it began with an E, we do this group. If it began with an L, this group. If we began with the other L, that group, and blah blah blah. And I should actually say, remember, we're not just looking at which letter it is, because these 2 L's, we're going to distinguish them. So let's say that I'm also going to mark these with the letter, with a number that they have written on them as well. So depending on which one of these blocks starts off that sequence, this is going to tell us where I'm going to put that sequence. But let's say that I'm looking now, I've got all my blocks, all my words or sequences rather, that begin with the H block. Then let's now further organize these. So now we're looking at the second block, and we're thinking, well, now we're going to organize all of those ones that began with an H. We're actually going to organize them into 5 different groups according to what the second block is. We did exactly the same thing, H to O, except actually we've already used an H in this case, so this, obviously there's going to be nothing here that has H as the second one as well. So just bear in mind that's going to be empty, but it's useful to kind of visualize what's going on. Actually, you know what, we can just scratch that off. I've changed my mind to scratch that off. But so we have E, L, L, and obviously the E is the 2, the L is the 3 block, the L is the 4th block, that's the 5th block. Okay, and imagine we do that to the same thing. Now, if we began with an E, we could have organized all of the blocks, the sequences that begin with an E, according to what the second one is, whether it's an H, whether it's an L. Be careful, there's no E anymore, is there? So, you know. Okay, and then O, 5, and there's no fifth one, there's only 4 in each. So imagine if we organise each of everything in these categories, right? Everything that gets sorted in the first 5 groups, we organise those groups even further according to the second letter. And then once we do that, we organise each of these groups, each of these groups at the end. 1, 2, 3, 4, 1, 2, 3, 4. Sorry, this isn't very neat, but the argument should be clear. So each of these groups here, we then organise according to what the third letter is. Now what you're going to get is you're going to have, to begin with, the first group we had, when we organised on the first letter, there are 5 different groups, because there are 5 letters that could have started off the codes, like the sequence of blocks. And then for each of these 5 groups, they gave birth to 4 lots of groups. So we have 5 lots of 4 groups, after we have now organised each of the initial groups according to, within each of those groups, we organise them according to actually what the second letter is. Now there are 4 options, because obviously we've already used one letter up, and we have 4 different letters to organise each of these baby groups into. So, and now we are at this stage, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different groups. And if we organise according to the third letter as well, so each of those groups we now have, we split them into now 3 groups each, and then we have 5 lots of 4 lots of 3 groups available. And if we keep going, organising according to the 4th letter, we have that, and then within each group we have then, we've already organised them according to what the first, second, third and 4th letter is. That doesn't leave us anything else apart from the 5th letter, that is the block that's remaining. So actually, there's only going to be one group in one way of organising the blocks in each of these 5 lots of 4 lots of 3 lots of 2, right? Because there's only one block left. So we can just scratch that. So that is how many sequences there are. But remember, we were saying earlier, the for each word that we have in these groups, you can have 2. There are going to be 2 different ones that are the same word. Okay, now if you think of what we've done now, we've organised all of our sequences into these groups, and that corresponds to a different ordering of these 5 blocks. But be careful. For, let's say, the word hello, that's going to be in 2 different groups at the end. It's going to be in its own group twice. So that word hello is counted twice, because the ordering matters, whether or not we had 3 followed by 4 or followed by 3. So actually, out of all these outcomes we have, each word is repeated twice. So we're going to divide by 2, because we need half the number of those, and that's going to give us the number of words available to us. Because for every code, every word we have, it gives rise to 2 different codes. Okay? And every code gives rise to a word. So we divide this by 2. And now you might have to think about this quite a lot. I advise you just to kind of like go through it more slowly. But basically that's going to cancel. And actually we get 5 times 4 times 3 words possible in this ordering. So that's going to be 20 times 3, which is 60. So going back to the probability that this baby spelt hello, actually spelt this word, it's 1 out of 60, as a probability. So one out of 60 chance that actually hello was spelt. So, it's quite likely, isn't it, that actually if this child did spell hello, then there's something more going on rather than just chance. Okay, thank you so much for listening. Thank you for tuning in with this episode. I hope you enjoyed it, and yeah, stay tuned for more. Okay, thank you. Bye.